Hello, my name is Derek from Tomcat Gas Training, and the short video you're about to watch is about one of these. Well, not just about one of these, about how to drain water out of one of these. So this is what we call a hot water cylinder, okay? Behind this lagging, which is like your expanding foam, there is a copper cylinder. Now these aren't very common now in houses because they've been replaced really by unvented cylinders, but we take a lot of these cylinders out. Now then, if one of these cylinders needs to be drained of water, the water comes out of the top here to feed the taps. So if we open the taps, we close the water off to the feed system, which will be up in the loft or above, at least a metre above this cylinder. It would drain the system but wouldn't drain the cylinder. Okay, so how do we drain this cylinder? Well, hopefully the plumber, gas engineer or whoever it was who fitted it would fit one of these, okay? And this is what's called a drain cock. Now, as you can see from here, the plumber didn't fit one, okay? So let's have a closer look at the drain cocks first, and then let's show you how you actually do drain one of these cylinders when this is broken, missing, or just generally can't get at in any situation. So let's get on with it and have a look at that. Now, as you can see here, I have two types of drain cocks. This one is a soldered in one. You can see I've cut it in half so we can see inside. But this one we would solder into a fitting. And this one has a 1/2 inch BSP. BSP stands for British Standard Pipe. Parallel thread. Okay, so that would screw into a female thread. So that's what would screw into the cylinder, the hot water cylinder. The internal parts are exactly the same. There's no difference between the two. Okay, so let's have a look at this a bit closer. So you can see here, if I take the actual insides out, you can see we have a seat here, and this is the hole where the water would escape. Yeah, so you can just see this raised bit here is the seat. Now on here there is a rubber washer. Okay, this rubber washer is made of Viton rubber because it has to be able to take over 85 degrees. So you can see the actual rubber washer sits flat with the seat, and as you undo you can see the actual rubber comes off the seat and allows the water to pass through the hole. So what can happen with this rubber is guys solder these in with this rubber still in position so it sticks on the seat. So it just flicks off the end when you try to take them off, so it stays over the seat so you can't get the water out. So never ever solder one of these in with that in, so you can just take them out first. So that's the first problem we have. The next problem we have is this shaft snaps and also leaves the seat down at the bottom, and there isn't enough pressure behind to force it open, or they just generally stick because they don't get used very often. So that's what it looks like inside a drain cock. So you can see the brass seat there and a rubber washer. Okay, and you can see how it screws in. So you would screw it righty tighty, lefty loosey. And you can see this one is exactly the same inside, and you can see they are the same. Okay, and obviously you can get different sizes. You can get 1/2 inch, 3/4, so you can get all different sizes to get you drained for the thread. Okay, so that's a closer look at the inside workings of these drains. Now let's nip on site and actually see how we're going to drain a cylinder when one of these has failed. Let's go and have a look at that now. Now, before we get started in looking at these videos on how to drain the cylinders, let's have a look and see how they were actually installed. Now this part of the video has been stolen again from one of my old videos, the insider boiler casing on the Baxi bat boiler. So you can see the copper cylinder behind the insulation there. And if we go down, you can see this white thing here. That is what's called the cylinder stat. And the cylinder stat is what controls the temperature of the hot water in this cylinder, which actually stops you getting burned. So we want to keep that below 65 degrees. So if we come up here now, this is the flow pipe coming from the boiler. So this is bringing up the hot water to feed the cylinder and the central heating. Now this is what we call a closed coupled system, where the vent pipe, which is on the left hand side here, it is actually within 150 of the cold feed. So the cold feed's where the water comes in, and the vent pipe is the safety device. So this is the pump. So you can see this part of the pump here would be under negative pressure because it's within the neutral point of the closed coupled system, and then obviously everything after the pump would be positive. So this is where the water flows in. You can see the arrow there, and if we follow the pipe down, this is going to a 3-port zone valve, so that makes it a Y-plan system. So this is where the water comes in, and this will be marked up as AB. This is going off to the cylinder, so that would be port B, and port A is going off to the central heating system. So this would flow down then to feed your radiators. If it was an S-plan, we'd have 2 valves here rather than the 1 valve. So this cylinder is an 1836 cylinder, so 18Y36 high, which is your standard cylinder sizes. So this is the feed system. Now it's not a tank, it's a feed system. So let's have a look inside the system. And there you can see there is a part 1 float valve. Now this float valve should be in here. This should be a part 2 float valve. Feed systems require part 2, not part 1 float valves for the water regulations. So always remember that. Part 2 can be fed for indirect water, but if it's going direct off the mains, you need a part 2. So we now can see the overflow pipe and the cold feed, and also we've got this pipe coming off the bottom of the cylinder is the cold water feeding into the cylinder. So we've got an isolation valve, and that gate valve should be higher than the cylinder, and as you can see, we follow it down, there is a drain down at the bottom there. That thumbnail valve there, you can see, is actually connected to the overflow for the cistern, which takes the water outside. This is our hot water off distribution pipe going to the vent pipe, and down that pipe at the back there would feed all the hot taps. So that's how you install a vented cylinder. And if you wanted to see the F&E, the F&E is actually in the loft up there somewhere. So how to drain a cylinder when you can't get on the drain. So we've turned the water off to the feed system. We've drained the water through the tap. We've now put a piece of 15mm all the way down to the bottom of the cylinder. We've then connected the hose. We've now run the hose all the way down the stairs to outside. Then you suck on the hose. It takes about 3 sucks on the hose, drop the hose down, and through siphonic action you will drain the cylinder. So that's how to drain a cylinder if there's no drain point, or the drain point don't work, or you can't get at it. So you now can see we've got this drain connected to this drain cock here, which is connected to the bottom of the cylinder like it should be. So we've run this hose pipe outside, all the way outside into the garden, open the drain, and away it goes. Now this is, it's not a common way of draining the cylinder, but we did do this at the council, where we connected the thumbnail vent onto the bottom of the indirect cold, which then went off to the overflow from the cistern. So another way of draining the cylinder. So other places you could actually find these drain cocks could actually be here. This is where the cold water comes from the storage cistern. So the cistern, which will be in your loft, will bring the water by gravity down into the bottom of the cylinder, and then we take the water off. So you could actually put the drain there and it would still drain the cylinder. But the best place would always be where the manufacturer puts the drain point. Now let's try and do an experiment to show you how siphonic action works. So this is some cordial in here. Nice warm day today. Anyway, the cordial's there just so you can see the colour. What I've done is put one glass higher than the other. I've got some clear tube. I'm going to put that into this glass, so I'm just going to a couple of sucks on here. And if by magic you can see the cordial is being taken out of one glass into the other glass. And that's how siphonic action works. If I lift this higher than the water, it breaks the siphonic action. Also, what we can do is if we fill the tube first and then put it in, it creates siphonic action without me even sucking. So that's one of the reasons why you make sure you run the hose pipe outside first before you put it into the cylinder, because you could actually create that siphonic action just by putting the hose into the liquid. So that's siphonic action. Cheers. That's the two ways of draining a cylinder. Use the drain on the cylinder with your hose pipe. Always make sure you turn the water off first. Okay? Or you can siphon the water out through siphonic action. Pretty much the same action as when you flush a toilet with a siphon in there. Displacing the air would suck it over. Now, in the video I've just shown you there on the hose pipe, always make sure you run your hose pipe outside first before you put it into the top of the cylinder, because you could also create that siphonic action by just putting the pipe over into the bottom of the cylinder, and it could naturally draw over in a siphon. And if you haven't run that hose pipe outside, you could be flooding the landing or the stairway. So always run your hose pipe outside. So if you've liked this video, why don't you give us a thumbs up, because it shows me you care, or leave a constructive comment down below. If you want me to cover any other subjects, why don't you leave a comment below and I'll try to cover those subjects. If you've not subscribed to our YouTube channel yet, then get subscribing, and don't forget to hit that notification bell, because I release videos every Wednesday. As usual, all I've got left to say is thanks for listening, thanks for watching. Tune in next Wednesday for another video. Cheers guys.